Greetings and welcome to my new calculus channel. My name is John Gabriel. In the previous members only video, we talked about the proposition on spheres and cylinders, the second proposition, which is this one here. And we left it at the point where I said I would continue with other notable propositions. So I'm not going to actually go through proposition 3, but the proposition 2 is used in proposition 3 in order to show that you can have the same principle applied to magnitudes of circles where you have parts of polygons that are measured. Okay, and this, by the way, leads into other propositions much later in Archimedes. For example, on page 283, there's the first proof that the area of a circle could be triangulated. That's the first proof, okay? So another proof is in his work on spirals. I think it's either proposition 16 or 18. But what I'm doing right now is I'm just getting all these things in order for you, and I'm not going to actually cover any of the details. To find out the details, you'll have to join the members only channel. And then you can see what we've already discussed and also what we're going to be discussing now. So on 283, let's go there. 283, we begin with the measurement of a circle, and we see the first time that Archimedes proves that you can square the circle. And the method he gives here is quite complex. Okay, in fact, it's very involved, but it uses polygons and the previous propositions. And the amazing thing about this proof, by the way, is it doesn't even bother to talk about numbers or anything else in terms of measurement. It's stating something about area without using any numbers at all. So the proposition says the area of any circle is equal to a right-angled triangle in which one of the sides about the right angle is equal to the radius and the other to the circumference of the circle. That's exactly what he proves also in propositions 16 through 21 of on spirals. But without using this, he uses spirals. And the typical method here is that Archimedes likes to put that which he is proving between two bounds. In other words, between a lower and upper bound. And you'll see more of that when we discuss it in the members only videos. So the next one is an interesting one. It's 285. So let's go to 285. 285. So Archimedes says the area of a circle is to its square on the diameter as 11 to 14. And Heath didn't even try to figure out this one. But it's probably because it's not an easy one to figure out. So what was Archimedes trying to do there? Well, he was obviously trying to approximate pi over 4. That's right. So Archimedes actually here states an approximation for pi over 4, which is 11 over 14. And Heath didn't notice this. And it's evident that he was flummoxed by this particular proposition. So he left it out. And contrary to what he says, that the text of this proposition is not satisfactory and Archimedes cannot have placed it before proposition 3, that's false. He could have. And it doesn't depend on the result of the proposition 3. But in any case, that's an interesting thing. And of course, you can state this in another way too. So rather than state it the way that, and I put Heath here, it's actually Archimedes, by the way, not Heath. Heath wishes he could realize something like that. I mean, if he were still alive. But another way to say it is to say that the circle quadrant area is to its radius as pi over 4 is to 1. Okay. It's nice and clean, isn't it? Okay. I'm not going to spend time on that, but I will cover all these things in details in the members only videos. The next thing is on 347 that I want to show you about. 347. And it's a kinematic curve definition. So it's proposition 1 of On Spirals, by the way. This is one of the most interesting books or works of Archimedes. If a point moves at uniform rate along a line and two lengths be taken on it, they will be proportional to the times of describing them. Okay, so that is the basis of kinematic curves, and we'll cover that also. And then in the following propositions, in 3 and 4, he gives a glimpse into the Archimedean effort of approximation, which is nothing like the fools of mainstream mathematics believe. Again, it goes back to what I discussed earlier, that Archimedes he bounds a particular area or value, whether it be an area or value or line segment. He binds it between two extremes, a lesser and a greater. And so he says, he proves by contradiction, he proves that it cannot be less and it cannot be greater, then it must be equal to that value. Okay. So almost similar to where you get your squeeze theorem from. Okay, but not quite the same thing. There are some differences. So these things and much, much more I'll be discussing in the members only channel. This is just an advertisement to those out there who are not already members. Now's your chance to become a member only, and you can do that by going to my channel and clicking on any of the videos. Okay, clicking on any of the videos like that. And then, of course, there is a join button. Right. Greetings. A join button right here. And press join. And voila, $4.99 a month only. You can have access to these gems and much, much more. So, I mean, basically, it's like you're buying me a cup of coffee every month. Am I not worth it? Surely I'm worth much more than that, right? Okay, so that's pretty much it. I'll leave it at that. I'll be going through what I've just described here in this outline, and hopefully I'll be chatting with the members only soon. I'm John Gabriel. This is a New Calculus channel. Goodbye.